This scientist and inventor almost destroyed humanity twice in his career. First, he gave a global poisoning, and the next time, his invention almost destroyed the Earth and died with his own invention. Yes, you heard it right. This is the story of Thomas Midgley Jr. He was born on May 18, 1889, in Beaver Falls, Pennsylvania. Raised in a family that valued education and innovation, Midgley displayed an early aptitude for science and engineering. His father, an inventor, and his grandfather, a prominent mechanical engineer, undoubtedly influenced his career path. Midgley attended Cornell University, where he earned a degree in mechanical engineering in 1911. This educational foundation set the stage for his future endeavors, combining a keen scientific mind with a practical approach. In the early 1920s, the burgeoning automotive industry faced a significant challenge: engine knock. This phenomenon, caused by the premature combustion of the fuel-air mixture in internal combustion engines, resulted in inefficient performance and potential engine damage. Midgley, working for General Motors, was tasked with finding a solution to this problem. After extensive research, he discovered that adding tetraethyl lead to gasoline could significantly reduce engine knock. The moment he discovered it, he called the owner and said, "We are going to be millionaires." And the story of greed starts. This discovery, patented in 1923, was revolutionary. Leaded gasoline quickly became the standard fuel for automobiles worldwide, dramatically improving engine performance and efficiency. General Motors, DuPont, and Standard Oil formed the Ethyl Corporation to market the new fuel additive, and Midgley became a celebrated figure in the scientific community. However, the success of leaded gasoline came at a tremendous cost. Even in the early stages of TL production, there were warning signs of its toxicity. Workers at the plants producing TL began to exhibit severe neurological symptoms, including hallucinations, tremors, and violent behavior. Some even died as a result of lead poisoning. Despite these alarming incidents, the Ethyl Corporation downplayed the risks, emphasizing the economic benefits of leaded gasoline. Midgley himself suffered from lead poisoning in 1923, requiring him to take a leave of absence to recover. Yet, he publicly defended the safety of TL, conducting demonstrations where he would inhale the additive's vapors to prove its harmlessness. These reassurances, however, were misleading, as the long-term health impacts of lead exposure were not yet fully understood. As leaded gasoline became ubiquitous, the environmental and public health consequences began to manifest on a global scale. Lead is a potent neurotoxin, and its widespread use resulted in elevated levels of lead in the atmosphere, soil, and water. This environmental contamination had severe implications for human health, particularly for children, who are more susceptible to lead poisoning. Leaded gasoline caused widespread lead contamination. When vehicles burned leaded gasoline, they emitted lead particles into the air, which then settled into the soil and water sources. Urban areas with high traffic density experienced the most significant contamination. According to studies conducted in the latter half of the 20th century, children living in cities had elevated blood lead levels, leading to cognitive impairments and behavioral problems. The Centers for Disease Control and Prevention reported that lead exposure could result in reduced IQ, attention disorders, and increased aggression among children. Adults were not spared either. Long-term exposure contributed to cardiovascular diseases and kidney damage. The detrimental effects of leaded gasoline contributed to a public health crisis that spanned decades, ultimately prompting regulatory action to phase out its use in the 1970s and 1980s. In 1975, the US Environmental Protection Agency began to regulate and eventually ban leaded gasoline, leading to a significant drop in blood lead levels in the population over the following decades. The legacy of leaded gasoline serves as a sobering testament to the unforeseen consequences of technological advancements. Undeterred by the growing controversy surrounding leaded gasoline, Midgley continued his career with a new focus: refrigeration. In the 1920s, refrigeration technology was in its infancy, and the chemicals used as refrigerants such as ammonia, methyl chloride, and sulfur dioxide were toxic and hazardous. Midgley sought to develop a safer alternative. In 1928, he introduced chlorofluorocarbons, a class of compounds that were non-toxic, non-flammable, and highly effective as refrigerants. CFCs revolutionized the refrigeration and air conditioning industries, providing a safe and efficient means of cooling that became ubiquitous in homes and businesses worldwide. Once again, Midgley's ingenuity appeared to have solved a critical problem, earning him accolades and further cementing his reputation as a leading innovator. However, the environmental impact of CFCs proved to be catastrophic. In the 1970s, scientists discovered that CFCs, once released into the atmosphere, underwent chemical reactions that depleted the ozone layer. The ozone layer is crucial for protecting life on Earth from harmful ultraviolet radiation. The thinning of the ozone layer, particularly over Antarctica, led to an increase in skin cancers, cataracts, and other health issues, as well as adverse effects on ecosystems. CFCs rise into the stratosphere, where they are broken down by ultraviolet radiation, releasing chlorine atoms. These chlorine atoms react with ozone molecules, causing the depletion of the ozone layer. The ozone layer's depletion allows more harmful UVB radiation to reach the Earth's surface, leading to a spike in skin cancer rates. The World Health Organization estimated that a 10% decrease in ozone levels could result in an additional 300,000 cases of skin cancer and 1.6 million more cases of cataracts globally each year. Additionally, increased UV radiation can damage crops, reduce phytoplankton populations in the oceans, and disrupt entire ecosystems. The realization of the ozone layer crisis prompted swift international action. The 1987 Montreal Protocol, an agreement to phase out the production and use of ozone-depleting substances, including CFCs, marked a significant milestone in environmental protection. The protocol has been largely successful in curbing ozone depletion, with atmospheric concentrations of CFCs gradually declining since the late 1990s. However, the legacy of CFCs remains a stark reminder of the unintended consequences of technological progress. Despite his profound contributions to science and technology, Midgley's later years were marred by health problems. In 1940, he contracted poliomyelitis, which left him severely disabled. Demonstrating his characteristic ingenuity, Midgley devised a system of pulleys and ropes to help him move in and out of bed. However, this invention ultimately led to his tragic demise. On November 2, 1944, Midgley became entangled in the device and was strangled to death at the age of 55. The spikes of lead poisoning and ozone layer damage killed thousands of people directly and indirectly and almost wiped out humanity. Thankfully, with technology and early detection, it was prevented by world collaboration. Thomas Midgley Jr. So life is a study in contrasts. A brilliant mind whose inventions transformed industries, and a cautionary figure whose work had unintended and far-reaching negative consequences. His story serves as a powerful reminder of the complex and often unpredictable nature of scientific and technological progress. Also, the extent a person can go to prove himself right and earn money. If you like watching such interesting content, don't forget to subscribe and check the video on screen to explore more.